Spotted. It seems like two giant stars were caught in the middle of a romantic kiss. This sounds a little bit like paparazzi fodder at first, but we're actually talking about a cosmic twist an international team of astronomers has discovered. So, the life cycle of a solar star is relatively simple. They're born in vast gassy areas of space, burn through their fuel, and at some moment they explode as supernovae. But when stars are born relatively close to each other, their gravitational pull can cause them some troubles and captivate them into what seems like an eternal dance. In some moments, they come so close to each other that they're practically touching. These stars may spend billions of years circling each other, but their kiss lasts for a few million years only, which is just a blink of an eye in cosmic terms. The lead author of this study, Leonardo Almeida, was on a mission to find these binary stars caught in such a cosmic kiss. He focused his search on the Tarantula Nebula, a beautiful star-forming region located in the Large Magellanic Cloud, which is 160,000 light-years away from our home planet. And there it was, the shiny double star system, VFTS 342, that stood out from the rest. The two stars found, they were pretty big and nearly the same size. Together, they make a mass about 57 times larger than that of our Sun. Before this, we discovered only 3 other binary systems with a large mass. And since these two stars were so close to each other, they created an intense gravitational pull. This made them orbit each other at a staggering rate of once a day, with their centers a mere 12 kilometers apart. With the stars being so close, they formed a bridge where their fuel could mingle, allowing for around 30% of their total volume to be shared between the two. Temperatures of this system were crazy, 41,000 at the 2. At first, it seems the internal mixing of their energy might make these stars live longer, as it allows for more fuel to be burned and for longer periods of time. But this is just a temporary benefit. There are 2 most likely scenarios for the star's ultimate fate. Like each diurodite, they could merge to form one giant star, which would eventually explode into a supernova, or they could each explode separately and live out their remaining years as black holes orbiting each other. If they merge, this process would probably take around 600,000 years, while if they become binary black holes, they could continue burning for another 3 million years. But both scenarios would ultimately lead to their destruction. Unless the stars could end up as 2 separate black holes, drifting away from each other through the vastness of space, there's a possibility for that to happen too. There's something spectacular stargazers across the globe could see recently. Jupiter and Venus, the 2 brightest planets in the sky, ended up so close it appeared like they were about to collide, or as if they were kissing too. At least that's what it looked like from here on Earth. In real terms, they're still 643 million kilometers away from each other. Here's another interesting thing astronomers like to talk about: G-objects. Those are celestial objects that look like clouds of dust and gas, but behave like stars. At the center of our galaxy, there's a supermassive black hole, Sagittarius A. It's 4 million times the mass of our Sun, and recently, scientists found out there are 2 mysterious G-objects that hang out pretty close to that black hole, so-called G1 and G2. And the most probable theory is that G2 are 2 stars that were orbiting the black hole in tandem and merged into an extremely large star cloaked in unusually thick gas and dust. During G2's closest approach to the black hole, it showed a strange signature. It was elongated, and much of its gas was torn apart. As it got closer to the black hole, it lost its outer shell, and now it's getting more compact again. The thing that has everyone excited about the G-objects is the material that gets pulled off of them by tidal forces as they sweep by the central black hole. This material must inevitably fall into the black hole, and the result is an impressive fireworks show. This happens because the material eaten by the black hole will heat up and emit radiation before it disappears across the event horizon. An event horizon is that scary boundary around a black hole from which nothing can escape. Now it seems scientists have discovered 4 more G objects, and they're all located within 0.14 light-years of this black hole. And it could be that all of the 6 objects used to be binary stars that got together and merged because of the powerful gravity of this giant black hole. Usually it takes over 1 million years to finish the merging process between 2 stars. We definitely want more G objects because it's one of the rare opportunities for us to study how things behave near a supermassive black hole without being swallowed. Yet, have you heard of variable stars? Looking up at the sky, we often think of the stars as unchanging, eternal lights. Yes, some stars might appear constant, but others change in brightness over time, which is why we call them variable stars. Some of them dim and brighten again over days, months, or even years. We can't see it with the naked eye. We're talking about changes astronomers can only notice using equipment and over longer periods. And how about vampire stars? Imagine 2 stars, a red giant and a white dwarf, in a binary system, swirling around each other like cosmic ballet dancers. The red giant, which used to be a vibrant and fiery star, has now aged and grown tired. Its outer layers of hydrogen, which were once held tightly by its gravity, have now weakened, making it vulnerable to the smaller, denser white dwarf. The white dwarf, known as the vampire star, thirsts for the hydrogen fuel that its larger sibling holds. And it sees a great chance there. As they spin together, the vampire star uses its powerful gravitational force to steal the hydrogen from the red giant's outer layers. The vampire star glows with a blue hue, looking full of energy and more youthful and vibrant than its age-dancing partner. Not only vampire stars, the horror continues with zombie stars too. Sometimes, when the red giant explodes, it doesn't completely break up into smaller pieces. Instead, a white dwarf remnant is left behind. It's basically a zombie star that was gone at one moment, but has risen back to life. But this isn't your average zombie hungry for brains. No, this star hungers for the very substance that its vampire sibling had been taking from it all along, hydrogen. And if the zombie star is close enough to its victim, it will start sucking material back in to start its core again. It will become a hydrogen explosive, ready to go boom in a spectacular show of cosmic revenge. It's a fascinating phenomenon. We usually won't even manage to detect it, because these explosions are much fainter than the usual supernovas. But when it does happen, the resulting blast is truly epic. And it destroys both the vampire star and its zombie sibling. It seems vampires and zombies may not be a work of fiction after all. Not only are we made of stardust, but we're also more similar to stars than we thought too. For example, stars also like to hang out with their close group of friends. Most stars prefer to travel through the universe in clusters. It's a group of stars that end up bound together by gravitational force. The stars in the clusters are mostly of the same age and type, hobbies and interests. I guess even they have better social lives than I do. Black holes, an enigma that has puzzled scientists and captivated our imagination for decades. But what's hiding inside of a black hole? Is it a void? A bottomless pit? A parallel universe? We don't know for sure yet, but scientists might have some ideas. So let's hear them out. Picture this. In the vastness of space, there's a supermassive star shining bright like a diamond. But like all good things, this star's party can't last forever. Eventually, it runs out of fuel and goes out with a bang. Quite literally, the star collapses under its own gravity, creating an implosion. Now, this collapse is so intense that it creates a bottomless pit in space, like a sinkhole. This is what we call a black hole, the ultimate no-escape zone, sucking up everything in its vicinity. including light. Imagine yourself approaching a black hole. The black hole itself doesn't emit any light, but you can notice a dazzling display of cosmic fireworks surrounding it. The accretion disk. It's like a celestial carousel of gas and dust swirling in a mesmerizing dance around the black hole. The incredible gravitational forces pull all this material from their surroundings, creating this celestial furnace. Of course, it's very unlikely that you would have survived in this place. Temperatures here soar to millions of degrees. Also, it's constantly dazzling X-rays and high-energy radiation that can be detected from telescopes on Earth. But let's imagine that you did survive, somehow. As you get closer, you notice a mysterious boundary looming ahead. The event horizon. It's a point of no return, beyond which the laws of physics seem to go haywire. Now, you're stuck in a space traffic jam, and no matter how hard you hit the gas, you're going nowhere. Once you cross this threshold, not even light can escape. And now, you inevitably fall into a black hole. What do you see around you? According to the genius physicist Albert Einstein, space and time aren't separate entities, but rather intertwined in a fabric called space-time. It's like a cosmic trampoline that can stretch and bend if you place something heavy on it, and black holes are super heavy, which is why they distort this trampoline in the most extreme way possible. So, when you venture close to a black hole, you're in for a roller coaster ride. The curvature of space-time becomes so intense that it's like a whirlpool pulling everything in, even light itself. Everything around you looks like a space funhouse with distorted colors and rays of light that keep shifting. All this makes you feel like you're doing the moonwalk on a treadmill. Also, the curvature of space-time around a black hole is so extreme that it creates a phenomenon called time dilation. Time near a black hole moves at a different pace than in the rest of the universe. The closer you are to the black hole, the slower time ticks, like a slow motion effect. And the deeper you fall, the weirder things get. The laws of physics seem to break down before your very eyes. But suppose you somehow manage to survive all this madness. Where exactly are you falling? What awaits you on the other side? Is there even an other side? As you venture deeper into this celestial maelstrom, you reach an elusive and mysterious point called the singularity. It's the heart of a black hole, a place where all matter and energy are crushed into a single, unimaginably dense point. Imagine cramming masses of entire stars to something that is essentially a pinprick. And now that you're here, forget about the usual rules of physics. Welcome to a new realm, where the known breaks down and the unknown takes over. So, what does this unknown look like? Well, there are a couple of theories. First off, it could be a gateway to other dimensions. What if there are multiple universes hiding within black holes, like nesting dolls? According to this theory, the interior of a black hole could be a portal to a parallel universe with its own set of physical laws and possibilities. This parallel universe could be drastically different from our own world. What a mind-bending idea! Or, what about wormholes? Imagine black holes forming a space subway system, connecting different regions of space and time with each other. These theories suggest that the extreme gravitational pull of a black hole could create a wormhole, a tunnel that could transport you to another galaxy, or even to the past or future. It's like finding a secret passage in a video game. That's not all. Some scientists propose that inside a black hole, we might find some exotic matter, some strange matter with weird properties or negative energy density. If that's the case, this would defy our understanding of the universe. And finally, One of the most mind-bending theories is that a black hole could actually lead to a white hole. Imagine, as you fall further, you suddenly find yourself in a blindingly bright space show. You're in a white hole. This is a fountain that's spewing out matter, energy, and information into the universe with reckless abandon. The birthplace of new universes. You see, while black holes are known for their event horizon, white holes have an anti-event horizon. With black holes, everything can enter and nothing can come out. With white holes, it's the other way around. They repel everything. White holes are hypothetical objects. Their existence hasn't yet been proven, but if it turns out that they exist, they could be connected to black holes. It makes sense. Black holes suck everything in, and white holes should take their matter from somewhere. And all this matter and energy coming out of the white hole could potentially form new universes. Together with black holes, they could form a universal cycle of creation. The end of one universe leads to the birth of another. All these theories are beautiful and fascinating, but here's the catch. There's still no concrete evidence of any of them. Black holes still remain one of the biggest mysteries of our world. Unfortunately, studying these mysterious beasts isn't easy. They're super elusive, and this is one of the biggest challenges for scientists. Black holes don't emit light, so they can't be seen directly. They're essentially invisible to telescopes that rely on light, making them incredibly difficult to observe. That's why scientists have to rely on things like X-ray emissions, the effects of a black hole's gravity on nearby objects, and other clues. They're also very unpredictable. For black holes, physics is like a fun playground. They warp space and time around them, which makes it difficult to predict and understand their behavior. But don't worry, space enthusiasts. The future of research in this field is as promising as ever. We've already made incredible discoveries. For example, in 2019, we captured the first ever direct image of a black hole. This is a central black hole of the galaxy Messier 87. A few years later, we also took a photo of a black hole in the center of our own galaxy, the Milky Way. This one is called Sagittarius A star. All this has opened up new avenues for research. And these aren't the only cool things we've discovered in recent years. Let's take gravitational waves, for example. You know how rocks leave ripples after falling into water? Well, gravitational waves are ripples in the fabric of space-time. They carry clues about the most cataclysmic events in the universe. They've allowed us to listen to the universe, unveiling previously hidden phenomena and events. And all these observations provide us with a new way to study black holes. We constantly make new advancements in technology. The James Webb Space Telescope will provide us with even more detailed observations and insights into the mysteries of black holes. There's still so much we don't know, but that's the beauty of science, the thrill of the unknown, and the curiosity that drives us to explore the mysteries of the universe. So, let's keep peering into the cosmic abyss on the thrilling quest to unlock the secrets of our world. Empty space is not really empty. At least that's what quantum field theory says. It's actually filled with tiny vibrations that can turn into virtual particles if they have enough energy. These virtual particles can produce packets of light with low energy called photons. Now, there's something every black hole has: an event horizon. It's a point of no return. That means once something crosses that point, it can never get away, not even light. And there's an insanely strong gravitational force around the event horizon. Black holes survive by gobbling up gas and stars around them. In most cases, a black hole has a swirling disk of material that surrounds it. called an accretion disk. It glows brightly as all those things that come too close to an event horizon get heated up and torn apart before the black hole swallows them all. As material comes closer, it starts to travel and move faster and faster, going all around the black hole. This makes the accretion disk glow and, at the same time, outlines the shadow of the black hole, which is basically the very event horizon we're talking about. Black holes might even want to hide, but they do so awfully badly. According to Einstein's theory of general relativity, gravity bends and warps space and time. It means that the closer you come to this extremely powerful gravitational pull around the black hole, the more twisted space and time around it become. That's what Stephen Hawking was talking about nearly 50 years ago, 1974. He also suggested that if these particles find a way to escape a black hole, they steal some of its energy, and because of these thieves, the black hole loses its energy as time goes by until it at one point completely disappears. He suggested that black holes release energy in the form of thermal energy, or heat, which is called Hawking radiation, and this radiation doesn't carry any information. It means that when a black hole evaporates, it destroys all information it had about the star that created the black hole. That way, we can't know what really happened. And it's kinda confusing because the laws of quantum mechanics say the information can't be destroyed. This conflict is something we call the Hawking information paradox. According to Hawking, all this information isn't really lost, but is stored in a cloud of all those zero-energy particles that surround the black hole. He called that soft hair. Now there's this new study as a possible solution to this paradox. Maybe Hawking radiation is non-thermal? Instead of just releasing plain heat, it's possible the black hole sends out a message in the form of radiation. This message contains important information about the black hole's past, the stars that formed it, and other details we thought were lost forever. It's like a secret code that tells us all about the history of the black hole. But let's go back to Hawking's theory, where a black hole can eventually disappear. It says that not only black holes produce Hawking radiation, any object with enough mass can. Researchers actually studied a process called the Schwinger effect too. It's when an electromagnetic field creates strong distortions and in that way forms matter. They applied this idea to Hawking's theory of black hole radiation. What they found is that the radiation Hawking predicted can actually be created in places with different levels of gravity, not just around black holes. Here's the key. When there are massive objects, like stars or planets, they create a curving effect on space and time. This curving is there because of their strong gravity. Even if you're far away from a black hole, there's still some massive object somewhere around that creates the curvings of space, which can make you feel like you're in that twisted space. It can create radiation, similar to what happens near black holes. It means that not only black holes can slowly evaporate, other massive objects in the universe can also lose their energy in the same way. If this is true, the energy of everything in the universe will slowly be drained away in the form of light particles. That means everything and everyone, including stars, planets, black holes, and us, share the same destiny, and will all eventually fade away. This sounds scary at first, but even if this theory is true, it's not going to happen anytime soon. It would take way longer than the current age of the universe for a supermassive black hole to completely disappear. So, in the way we measure time, black holes are basically eternal. And stars could last even longer since many black holes formed after some giant star collapsed upon itself. Some others belong to a group called primordial black holes. Hawking, who became famous for talking about black holes, mentioned those ones as well, and the theory says they probably formed spontaneously in the early universe, not long after the Big Bang happened. Hawking realized that primordial black holes could have different sizes, from very light to very heavy. Really small ones would have disappeared by now, because of Hawking radiation. There's a pretty cool idea that these primordial black holes could be dark matter. It's a mysterious substance that scientists think exists in the universe. It doesn't give off or reflect light. so we can't see it directly. Scientists think dark matter might explain why stars and galaxies move in strange ways, but we still don't have the tools yet to confirm whether these black holes really exist, or if they're actually made up of dark matter or not. Hawking also explored the idea that our universe is just one of many universes. It's a concept called the multiverse. Some scientists believe it could be that any situation you can imagine in your life is happening somewhere in some other universe. Hawking didn't agree with that, so in his final paper, he proposed a new mathematical framework that made the multiverse finite instead of infinite. This means that there would be a limited number of universes rather than an infinite number. Another thing that's hard to test and prove, but at least he left us with something to think about. Believe it or not, time travel is not that impossible according to the laws of physics. Scientists have equations that suggest we could have something called closed time-like curves that might allow us to go back in time. Imagine going back to the most embarrassing moments of your life. Knowing what would happen, you could avoid them. But here's the tricky part. Going back in time could cause some big problems. It could create situations where things would happen in a way that doesn't make sense. Imagine you're walking down the street and meeting your younger or older self, or accidentally changing things that have already happened. Hawking was talking about this part too, and these are all things that made him concerned about time travel. He made a guess called the chronology protection conjecture. He suggested there might be a rule of nature that stops time travel from happening because it could create all these strange and confusing situations where we would just go back, fixing our wrong decisions rather than living in the present. Until we discover traveling through time without causing such disruptions, I guess all we're left with are life lessons and learning from our mistakes. In his last years, Hawking talked about the future of humanity, and we still don't know if he was totally serious. He mentioned a special particle called the Higgs boson that could cause a big bubble that could gobble up and eventually even destroy the universe. He also mentioned things like beings from other planets coming to Earth and conquering us, or robots becoming smart enough to take over the world. Some of his ideas turned out to be true, and time will tell if it will be the same with the others. Imagine a place where a single day lasts longer than a whole year. On Venus, a day, meaning one full spin on its axis, is as long as 243 Earth days. And what's even weirder, despite the fact that Venus is experiencing a never-ending day, it has a shorter year than Earth. While Earth takes about 365 days to complete one orbit around the Sun, Venus does it in just 225 days. So, somehow for Venus, a day is more epic than a whole year. Venus is a strange planet in general. It's called Earth Twin because of how alike we are, although it's a bit smaller than Earth. But there are some drastic differences too. For example, it spins in the opposite direction, which means the sun there rises in the west and sets in the east. And Venus isn't the only one who dances to its own rhythm. Uranus does that too. And finally, Venus is quite crazy in terms of its atmosphere. When you stand on Earth, you don't really feel the weight of the air around you. Well, on Venus, that feeling would be like having an elephant sitting on your shoulders. Venus has 90 times the atmospheric pressure of Earth. The atmosphere there is a thick layer of toxic gases. For example, carbon dioxide that's released by all the volcanoes. It presses down with incredible force. This results in incredibly hot temperatures. No wonder it will take a long time before we'll be able to stand on this planet. Up to 3-sec pause. Meanwhile, Mercury, the closest planet to the Sun, has an even more speedy orbit than Venus. It completes a full journey around the Sun in just about 88 Earth days. However, it has a slow spin on its axis, which means that one day on Mercury takes about 176 Earth days. Basically, a half a year. Just like with Venus, a day there takes much longer than a year. Since it's the closest to the Sun, no wonder Mercury experiences some super extreme temperature swings. Daytime temperatures can soar up to a scorching 800 degrees Fahrenheit, hot enough to melt lead. But wait for sunset. At night, it drops to freezing minus 290 degrees Fahrenheit, That's because Mercury doesn't have a thick atmosphere like we do, so the heat doesn't distribute across the planet evenly. If one side is in the dark, it will be super cold, and the other side will be scorching hot, just like if you let a regular big rock lie down under the sun for a while. In fact, it's so cold that there might even be some ice on it. Look at the planet's North Polar region, especially at those sunlit yellow spots inside craters. These are indications of water ice. Turns out, water is much more common in space than we thought. Sucker 3-sec pause. Mars is often dubbed the Red Planet. It earns this nickname from the abundance of iron oxide, or rust, covering its surface. The iron-rich minerals create a rusty red hue that paints the Martian landscape. But turns out, Mars isn't just red. If you were standing on Mars, you'd witness desert-like butterscotch terrain with caramel and golden glows, some brown, and even a glimpse of a slight greenish hue. Mars also has the biggest mountain in the entire solar system, Olympus Mons. Standing at a staggering height of about 13.6 miles tall, it's even taller than Mount Everest. It was formed by the eruption of low-viscosity lava, creating a shield-like structure. Since Mars is covered in sand, it's also famous for its crazy dust storms. But it turns out, they're even more insane than we thought. These storms can last for months. While they might present challenges for future human missions, they also contribute to the planet's mesmerizing appearance when observed from afar. And not only storms, but even its own Marsquakes. Also known as seismic tremors, they were first detected by NASA in 2019. Unlike earthquakes that are often triggered by tectonic plate movements, Martian quakes are thought to result from the cooling and contracting of the planet's interior. It's interesting how similar yet different the planets are. Uchbawar 3-sec pause. Saturn's iconic rings might hold a secret linked to Earth's ancient past. The rings are composed mainly of ice particles and debris, and are estimated to be relatively young in space terms, perhaps just a few 100 million years old. Now, there are some theories that propose that they were born after some catastrophic event. For example, the collision of two large moons, or the breakup of a comet. What's interesting is that this timeline coincides with the age of the dinosaurs' demise on Earth. While Saturn takes the crown for its rings, it's not the only planet in our solar system sporting them. Jupiter, Uranus, and Neptune also have their own sets of rings, although they might not be as visible and cool as Saturn's. However, there's something where Saturn truly stands out: the magnificent hexagon at its North Pole. It's a colossal six-sided figure. Each side of this incredible structure measures around 9,000 miles long, which is 1,200 miles longer than the Earth's diameter. Scientists aren't sure how it was formed or why. They think that it might be due to varying wind speeds, or maybe it's shaped by a localized, slow, meandering jet stream. So far, it remains another of Saturn's mysteries. 5. 3-sec pause. Much like Saturn's hexagon, Jupiter also has its own weird spot. It's called the Great Red Spot. This is a storm that has been raging for at least 350 years and is larger than Earth itself. Despite its name, the spot's coloration has varied over the years, ranging from brick red to pale salmon. Scientists continue to study this enduring storm, unlocking the mysteries of its persistence and ever-changing hues. Meteorologically, the Great Red Spot is a powerhouse. It generates enormous pressure in Jupiter's southern hemisphere. Meanwhile, Jupiter itself is a powerhouse when it comes to magnetic fields. Its magnetic influence is colossal. It extends far beyond the planet itself and creates one of the largest and strongest magnetic fields in our solar system. Because of that, Jupiter is a source of intense radiation and mesmerizing auroras. While Earth's northern lights are breathtaking, Jupiter has something to offer too. The magnetic field interacts with charged particles from Jupiter's moons and the solar wind. This creates visually striking auroras near its poles. But compared to Earth, the scale of these auroras is incredible. Nothing like we've seen on our planet. But even having a cool big spot isn't a unique feature in our solar system. A stormy giant Neptune, the 8th and farthest planet from the Sun, also has its own great dark spot. Just like with Jupiter, it's a massive vortex in Neptune's atmosphere. But unlike its Jupiter counterpart, This spot tends to come and go because of Neptune's dynamic and ever-changing weather patterns. Neptune, together with Uranus, is known as an ice giant, and just like other giants, it boasts some of the most ferocious winds in our solar system. Its supersonic winds can get faster than 1,200 miles per hour. What a drama queen. But this explains its thick cloud formations. By the way, if you ever dreamed of a planet raining diamonds, you might want to visit this planet. Deep within Neptune's atmosphere, where pressures are extreme, scientists theorize that carbon atoms are compressed and form diamonds. And then, these diamonds might be raining down. What a unique touch to stormy weather. Neptune's moons got from their parent with the weird weather. For example, its largest moon, Triton, has a touch of cryovolcanism. Instead of spewing molten rock like Earth's volcanoes, Triton's cryovolcanoes erupt with a mix of water, ammonia, and nitrogen. Picture it as icy geysers shooting material into space. Seems like, in our solar system alone, each planet has its own quirks and interesting qualities. Let's hope that we discover more interesting things in outer space in the future. In 2017, a strange object was spotted in our solar system. It had the shape of a long tube, similar to a pancake. No known asteroid or comet we've seen looks like that. Its exterior was also peculiar. It was at least 10 times more reflective than the average stuff that flies through space, with some saying it had a surface similar to polished metal. When it went past the sun and left our reach, it accelerated faster than what our gravity could account for. At first glance, it was like this thing had a rocket strapped to its back. This unusual visitor even got a special name, Oumuamua, O Muir Muir. It comes from Hawaiian and translates to scout or visitor from a faraway land. And because of its characteristics, scientists soon began to wonder if this was at last a visit from otherworldly creatures. 1-3 sec pause. Before they went full-on with the science fiction suppositions, astronomers gathered the information they were sure about, starting with the fact that Oumuamua must have come from another solar system. There must have been some unfortunate event in its home system that led to its ejection. What they didn't know was if this was a comet or an asteroid. They're both celestial objects orbiting a sun, but they have distinct compositions and behaviors. Comets are composed primarily of ice, dust, and rocky material, often referred to as dirty snowballs. When a comet approaches the sun, the heat causes the ice to vaporize, releasing gas and dust particles into space. This creates a bright glowing tail that can extend for millions of miles. Comets generally have elliptical orbits, often taking them from the distant reaches of the solar system closer to the sun. 3 sec pause. Asteroids, however, are mostly made of rock and metal. In our neighborhood, they are remnants from the early formation of the solar system and are typically found in the asteroid belt between Mars and Jupiter. Unlike comets, asteroids do not develop tails when they approach the sun, as they don't have ice. Their orbits generally follow more circular paths compared to comets. By all accounts, Oumuamua should be a comet because it seems to come from a different location in the universe, yet it doesn't exhibit the typical signs of cometary activity. Wait a minute, am I doing a commentary on cometary? Nah, never mind. Oumuamua lacks a tail and does not spew out gas as it passes by. Not like me. Even though it behaves like a comet, it looks more like an asteroid. I'll read 3 sec pause. Another big question is how scientists even managed to spot Oumuamua in the first place. Considering the vastness of space and time in the galaxy, it's remarkable. Stars have lifetimes spanning millions or billions of years, and the formation of a solar system takes hundreds of millions of years. Even the fastest objects take tens of thousands of years to travel from one star to another. In contrast, humans have only been observing the skies with telescopes for around 400 years, a tiny fraction of cosmic time, and it's only in recent decades, even years, that we've had the technology to detect and track fast-moving, dim objects. Either rocks like these are abundant, or we've been incredibly lucky with our detections, or it simply wanted to be seen. Or 3-sec pause. Another question that was asked was where such objects could come from. It's highly unlikely that Oumuamua came from a mature, stable solar system. That's because such systems don't eject enough material to fill up the galaxy. Occasionally, a random rock might get flung out, but it can rarely travel so far. Young systems, however, act differently. In these chaotic environments, collisions, mergers, and migrations are happening everywhere. Plenty of tiny rocks roam around, perfect candidates for ejection. The solar system that kicked Oumuamua out must have had a planet similar to Jupiter. Its massive size and gravity could influence other objects in the system, causing potential ejections. But not all solar systems develop Jupiter-sized planets. Often, massive planets end up close to their stars, becoming hotter versions of Jupiter. These planets, snugly orbiting a sun, are less likely to eject debris. Neptune-like planets might play a role too. While not as massive as Jupiter, they tend to call the outer regions of solar systems their home. Our solar system has the Kuiper belt, a reservoir of comets in its outer reaches. During a solar system's early stages, interactions between Neptune-like planets and debris are common. Finding Neptune-like planets in other systems has been challenging though. Our methods for detecting exoplanets work better for massive objects close to their stars, making it difficult to spot Neptune counterparts farther out. A 3-sec pause. Oumuamua was also linked to a peculiar theory about how life came to be in the universe. Panspermia. It's a hypothesis that suggests life exists throughout the universe and can be distributed between planets by various means, such as asteroids, comets, and even spacecraft. It says that life must have originated in one location in the universe and then spread to other celestial bodies. Fans of the panspermia theory have suggested that such interstellar objects could potentially carry tiny microbes, those building blocks of life between star systems. If such objects were to impact a planet or a moon, they could transfer these materials and seed the celestial body with life. For now, there is no evidence to support the idea that this comet in particular has transported life between star systems. Auker 6, 3-sec pause. After years of research, the overall consensus became that Oumuamua was indeed a comet. The reason why it moves strangely is because it might have frozen hydrogen on its surface that reacts when touched by sunlight. The closer it got to our sun, the faster it became, releasing that hydrogen, and also changing its path through our solar system. Its color also supports this theory. It's red, which might mean it's been hit by cosmic rays for a long time. The longer it was touched by those rays, the more hydrogen it gathered in the process. But since they can't be completely sure, astronomers have a plan to follow this visitor. One idea is to send a mission to check it out. It's already far away from us, but it may not be too late just yet. We may be able to send a probe fast enough to catch up with the comet. The plan was named Project Lyra and aims to use the Earth's orbit and that of Jupiter to bounce out a probe far enough to reach Oumuamua. If it works, it will be the fastest space device we've sent out in the universe. One potential trajectory of the space probe involves using the gravitational pull of our planet and that of Jupiter as a lasso effect, but not Ted Lasso. The probe will leave our planet and re-enter Earth's orbit before sending it to meet with Jupiter's pull. It will be sent back near our planet a second time, where it will be ejected with enough force to reach the comet. Second 3-sec pause. Project Lyra also aims to follow a second faraway visitor named Borisov. This one was discovered by an amateur astronomer and now bears its name. What's interesting about it is that, well, it's spotless. Similar to our experience with Oumuamua, we haven't seen anything like Borisov before either. Studies of the light coming from its cloud of dust and gas show it's very clean compared to other space objects. Do you know how many continents there are on Earth? That's an easy one. 7. But wait a second, aren't Europe and Asia one large continent, Eurasia? It looks so when you look at the world map. Well, scientists think differently. They don't just look at bodies of land sticking out of the sea. Geoscientists study the types of rock that continents are made from. When you see the world from their perspective, the number of continents actually increases. Yes, they are not a myth. Lost continents exist. Or, at least they used to. They are hiding under other land masses. Peekaboo! Researchers have recently discovered one continent just like that. It is called Greater Adria. Sounds familiar? Yes, it has something to do with the Adriatic Sea, the Mediterranean. This lost continent is completely buried under Europe. It collided with Europe and started to sink under it a long time ago. Today, it lies beneath Italy, Greece, and the Baltics. Its size and even shape match that of Greenland, the world's largest island. But how did geoscientists find Greater Adria? It's no longer visible, but it left some clues. Parts of it were embedded in the Alps. Other chunks were incorporated into present-day Italy and Croatia. On the other side of the Adriatic Sea, limestone rocks from the former continent started to change once they were under the European landmass. Tremendous heat and pressure spread over tens of millions of years changed their structure. Out goes the limestone. In comes the marble. All the Greek and Roman temples you admired on your summer vacation were constructed using this marble. It was sort of a going-away gift from a long-lost continent. Greater Adria camouflaged itself well for thousands of years, but other lost continents were hiding in plain sight. Have you heard of Earth's 8th continent, Zealandia? Probably not, because it sits under the surface of the Pacific Ocean. 95% of Zealandia is now underwater. Can you guess where exactly? Its name is a good hint, under New Zealand. If you open Google Maps, you can see its outline. Look for a lighter shade of blue in the ocean. It should stretch from New Caledonia to New Zealand. This bump in the ocean floor used to be above sea level. It was about 2/3 of Australia and more than twice the landmass of Greater Adria in size. We can spot Zealandia today because it hasn't sunk too low, and that's the best way to discover other lost continents. Imagine the Earth without the oceans. The bottom of the sea isn't flat. There are mountains and trenches. You could put Mount Everest in the deepest of them, the Mariana Trench, and there would still be 2,133 meters between it and the sea level. This trench got so deep because of a geological process called subduction. The Pacific Plate got under the Philippine Plate. Earth's crust is made out of those plates that float in a sea of molten rock. Then they bump into each other. One goes down, while the other one rises. That's how Greater Adria ended up under the European continent. Our planet is constantly on the go. We don't notice this process because it happens deep beneath our feet. 120 million years ago, Australia and Antarctica were a single piece of land. Antarctica said goodbye to Australia, but it didn't leave empty-handed. Today, there is an oceanic plateau in the Indian Ocean. The word plateau comes from French, and it means elevated flatland. And the name of this land sounds like the title of a Hollywood movie, Broken Ridge. Long ago, it was connected to another lost continent, the Kerguelen microcontinent. Scientists believe that it made a land bridge between India and Antarctica. What was this land like? The answer possibly lies in a tiny archipelago in the southern Indian Ocean, Kerguelen Islands. These islands are all that is left of the ancient landmass. They have a cold climate. The islands feature glaciers because they are so close to Antarctica. But in the past, the climate must have been temperate with plenty of rainfall. The animals and plants would have been similar to those that we find in tropical regions today. The lost continent's landscape probably resembled that of New Zealand. While we are in the area, can you guess which continent the island state of Madagascar once belonged to? If you guessed Africa, sorry, you were wrong. Hey, don't feel bad. Look up and to the right on the map. The correct answer is India. Some 120 million years ago, I wasn't around then, India separated from the African continent and went northeast. Madagascar wasn't quick enough and ended up as an island off the southeast coast of Africa. Scientists found traces of the ancient landmass under the island of Mauritius. Today, it's a tourist hotspot, but millions of years ago, it was a real hotspot, volcanoes and all. That's how scientists were able to retrace the steppes of Mauritius. They found a mineral, zircon, that exists in rocks which lava spews out after an eruption. The long-lost land once covered the area from Mauritius to the west coast of India. Imagine if that land existed today. It would form a great mix of Indian and African cultures. Speaking of spicy, have you had Indonesian food recently? Just 50,000 years ago, Southeast Asia looked much different. There was no Sumatra, Borneo, Java, or even Australia. Just Sunda and Sahul, two continental masses that were divided by a deep water trench. You had the extension of mainland Southeast Asia on one side, Sunda, and the Greater Australia, Sahul, on the other. Biologists were among the first scientists to notice the split. Species develop differently on Sunda and Sahul. That's why Australia has unique animals such as the kangaroo, wombat, and platypus. And did you know that a giant kangaroo once roamed the island of New Guinea? That's because, up until the end of the last age, there was a land bridge to Australia. But it's quite shallow, less than 20 meters. It's a reminder that this was once a single landmass called Sahul. Another ocean strait that isn't too deep, Alberkats, 50 meters, separates Asia from North America. The Bering Strait sits today in the place of Beringia. This ancient landmass wasn't that big. It stretched 1,000 miles from north to south. That's just a third of the driving distance from Los Angeles to New York. Beringia was important for another reason. During the Ice Ages, it connected the whole world. Water levels then were 90 meters lower than they are today. If they went even lower, you could walk from the Cape of Good Hope in Africa all the way to Cape Horn in South America. Today, you can hop on an airplane and fly to pretty much any place on the globe. The world has never seemed smaller, has it? Well, it has. Some 300 to 200 million years ago, we were all one world, literally. Pangaea was a supercontinent that included all the continents. Its name is in Greek, and it simply means all Earth. But Pangaea started to crack up. The biggest gap formed between the Americas on the one side and Europe and Africa on the other. Seawater soon started pouring in, and that's how we got the Atlantic Ocean. This process is by no means over. While you are watching this video, North America is drifting further and further away from Europe at the rate of 2.5 centimeters per year. Doesn't seem much when compared to the average human lifespan, 70 years. But in the end, all the continents will reconnect with each other, forming a supercontinent, and it wouldn't be the first time in Earth's history that this happens. Honestly, I'm not going to wait around for that. These eerie objects are called quasars. They're some of the brightest and most powerful objects in the universe. They lurk in the depths of space, consuming entire galaxies with their insatiable hunger. Muhahaha. But what are quasars? Where do they come from? And most importantly, are they dangerous to us? Come on, let's find out. Picture a supermassive black hole, a cosmic monster so massive that it can swallow entire stars and bend the fabric of space and time. Usually there's such a black hole in the center of every galaxy. That includes our own Milky Way galaxy. Ours is named Sagittarius A star. Sounds like the name of a hipster coffee shop, but in reality, it's a terrifying celestial body, which is 4 million times heavier than our sun. You could even see it online. For the first time, we took a photo of this black hole in May 2022. But don't worry, even though it's supermassive, it's not going to swallow us up anytime soon. This black hole is relatively small, and it's too tiny to eat an entire galaxy, so it's more like a cosmic vacuum cleaner that sucks up stars or gas that get too close. But there are black holes in the centers of galaxies that are way heavier and more dangerous than ours. They can weigh millions or even billions of times more than our own sun. Now, imagine one of these monsters. Usually they're surrounded by a swirling, glowing disk of gas and dust, like water swirling down a drain. It's called an accretion disk, and it's where the magic of quasars happens. As material from the accretion disk falls towards the center, it heats up to millions of degrees, releasing vast amounts of energy in the form of radiation. And this radiation is what we observe as a quasar. So basically, the more material a black hole can consume from its surroundings, the brighter its quasar will be. This is what makes them so bright and powerful, shining like beacons in the night sky. And just imagine, some black holes can actually make entire galaxies their meal. Now, combine their ravenous appetite with some intense radiation, and you'll get a truly awe-inspiring display of cosmic power. No wonder we can see them even though they're some of the most distant objects in the universe. Quasars were discovered in the late 1950s by accident. Astronomers were just chilling and looking at the sky when suddenly they stumbled upon something strange, radio signals that had no visible source. By 1960, hundreds of these strange objects had been found. Astronomers named them quasars, short for quasi-stellar radio source. These objects were small and far away, but their energy output was immense and difficult to explain. Some thought that these were new types of stars. Others even proposed wild things, like quasars being made of antimatter or being the end of a wormhole. But all these theories were discarded. A scientist named Martin Schmidt was the first one to get to the truth. However, many astronomers didn't believe him. Schmidt had to do a lot of extra work and gather lots of evidence to prove his theory. And finally, he prevailed. That's how we discovered quasars. Don't you love the scientific method? And since then, astronomers have been captivated by these objects. Why? Because they have some pretty eerie qualities. You could call them quasi-quasars. For example, they kinda defy the laws of physics. They emit jets of particles that travel at speeds close to the speed of light. These particles move so fast that they can even distort the very fabric of space and time. But sometimes they help us confirm the laws of physics. Imagine driving a car. As you drive, objects in the rear window start to appear smaller and smaller until they disappear from view entirely. That's exactly what happens with quasars, except they're moving away from us at incredibly fast speeds, up to 90% the speed of light. Wonder why they're trying so hard to sprint away from us. But in any case, this helps us confirm that the universe does expand for real. Another eerie thing about quasars is that they're incredibly old. Some even date back to the time when galaxies were forming, or to the birth of our universe. Additionally, quasars are some of the most distant objects that we can observe in the universe. Some of them are located billions of light years away from us. This means that when we observe a quasar, we're actually seeing light that was emitted billions of years ago, when the universe was much younger and different than it is today. And that's why they work like cosmic time capsules. Studying them gives us a glimpse into the distant past. You see, galaxies are like giant cities, with stars and planets serving as the inhabitants. But just like cities evolve over time, galaxies also undergo changes as they age. And that's where quasars come in. They are like the urban planners of the universe. They shape the galaxies through their powerful gravitational influence. By eating galaxies and releasing intense radiation, they can trigger star formation and shape the structure of the galaxy itself. It's like the cosmic equivalent of a master chef or a leaf blower. You pick. For example, let's take galaxy mergers. Picture two massive entities coming together, swirling and spinning around each other. As they get closer and closer, their gravitational pull becomes stronger, and they start to merge into a new, bigger galaxy. It's a beautiful and dramatic process, one that can take millions of years to complete. But all this doesn't go without consequences. The gas and dust within the galaxies collide, creating massive shock waves that trigger the birth of new stars and even supermassive black holes. And this is where quasars come into play. Some quasars may be born during these galactic get-togethers, and thanks to this, they help us study the effects of this process and the evolution of galaxies over time. But it's not all serious science and no fun. For example, how about gravitational lensing? Now, that's something straight out of a sci-fi movie. It happens when the gravity of a massive object, like a quasar, bends the path of light from a more distant object, like a galaxy, behind it. It's like having a really big magnifying glass in space. When you combine a quasar with gravitational lensing, you get some seriously awesome cosmic eye candy. The result is kinda like a funhouse mirror, where objects appear warped and twisted in strange and mesmerizing ways. Oh, so that's what happened to me. Gravitational lensing isn't just for show. It's also a powerful tool for astronomers to study the distribution of dark matter and the structure of the universe. And that's not all. Some scientists have proposed that quasars could help us to build the map of the universe. They can work like giant neon road signs. Turn left at the quasar and you'll reach your destination. They're like lighthouses that help us navigate through space. By analyzing the light from different quasars, astronomers can determine the distances between them and create a 3D map of the universe. And the best part? Quasars are located throughout the entire universe. That's why this cosmic map can give us a comprehensive view of the universe on a scale that was previously unimaginable. Who knew that a giant galaxy eater could be so useful? Hundreds of millions of rocks orbit the sun within the asteroid belt between Mars and Jupiter. But only some of them come relatively close to Earth. NASA classifies asteroids orbiting within 48 million kilometers of our planet as near-Earth objects, NEOs. And inside this group, there are particularly worrisome objects. Those are so large and orbit so closely to our home planet that they could turn into a real threat to the world should a direct collision occur. At the moment, NASA is keeping a close eye on an asteroid named Bennu. It's a fairly large space object, 610 FT across, that might smash into our planet in 159 years. According to experts, the asteroid, which was first spotted in 1999, is quite likely to drift into the orbit of our planet. If it happens, it might collide with Earth by the 24th of September, 2182. Asteroid Bennu is thought to be taller than the Empire State Building. If it hits our planet, the collision will release 1,200 megatons of energy. That's an enormous amount of energy that nothing built on Earth could produce. Scientists from NASA believe that, during the flyby in the 22nd century, there is a tiny chance that the asteroid will pass through a gravitational keyhole. That's a region of space that might set the space traveler on a certain path, which could result in the asteroid crashing into Earth. Bennu flies by our planet every 6 years. It has had 3 close encounters with Earth, in 1999, 2005, and 2011. These days, scientists estimate the chance of the asteroid hitting our planet by 2182 as 1 in 2,700. That's more than 5 times a person's chance of being struck by lightning. But even though Bennu's chances of colliding with Earth are quite low at the moment, the space rock has still been categorized as a potentially hazardous asteroid, all because it might come as close as 7.5 million kilometers from Earth. That's the reason why it's also classified as a near-Earth object. Bennu is a carbon-rich asteroid that formed in the first 10 million years of the history of the solar system. That's around 4.5 billion years ago. No wonder this space body holds precious clues to the origin and development of the rocky planets of our solar system, which are Mercury, Venus, Earth, and Mars. Even better, it may contain organic molecules similar to those that are crucial for life to evolve. In 2020, NASA's OSIRIS-REx Origins, Spectral Interpretation, Resource Identification, and Security Regolith Explorer managed to briefly touch the surface of the asteroid. It collected some sample space rock afterward. For NASA, it was the first mission of this kind, but it won't probably come as a surprise that Bennu isn't the only asteroid we should worry about. Asteroid 99942 is another space body we'd better watch out for. It's a near-Earth object about 335 meters across. It was discovered in 2004, and at first, it was identified as one of the most dangerous asteroids ever detected. Apophis gained notoriety very fast. It was believed to pose a serious threat to Earth. Experts predicted that it would come uncomfortably close to our planet in 2029. Luckily, after a more careful examination of Apophis and its orbit, astronomers concluded that there was no risk of the asteroid colliding with our planet for at least a century. The risk of an impact in 2029 was ruled out completely, as well as the potential impact that could be caused by the asteroid's close approach in 2036. Interestingly, until March 2021, there was still a small chance of a collision in 2068. But then, Apophis made a flyby of Earth, and astronomers took this chance to use powerful radars to estimate the asteroid's orbit around the Sun more precisely. This allowed them to rule out any impact risk for at least the next 100 years. Now, the reason why such discoveries make us so worried is that even a relatively small asteroid, the size of a house, can wreak havoc upon colliding with our planet. And if an asteroid is larger than 1 kilometer across, astronomers call it a planet destroyer. The impact energy released by such an asteroid after striking Earth could be devastating. That's why knowing where such asteroids are and in what direction they are moving is crucial. The problem is that our capability to protect the planet from asteroid impacts is not top-notch yet. If such a catastrophe was about to occur, we would need pretty much time to prepare, because an asteroid collision is no joke. Probably the most well-known asteroid impact site is the Chicxulub crater. It's the evidence of the terrifying collision that led to the extinction of dinosaurs. Strangely, this crater isn't very visible, but some others are. For example, Barringer Crater in Arizona, which is also called Meteor Crater. It looks rather blood-chilling when you think about the collision that led to its appearance. In any case, we now know that space rocks hit not only Earth, but also the Moon, Mercury, and Mars. No rocky planet in the solar system is safe from asteroid impacts. That's why we have an entire scientific enterprise whose goal is to find and catalog the asteroid population of the solar system. It might sound a bit scary, but there are around 25,000 asteroids larger than 140 meters in diameter near the orbit of our planet. Such a space rock is large enough to wipe an entire city off the face of the Earth. So far, less than 50% of such asteroids have been detected and tracked. There are also an estimated 230,000 objects equal to or larger than 49 meters in size. Those are capable of destroying a concentrated urban area. And still, fewer than 8% of those have been detected. There are also tens of millions of smaller, near-Earth objects. They are larger than 10 meters across and might cause some surface damage. Less than 1% of such small space bodies have been discovered so far. The thing is, the inner solar system is extremely challenging for asteroid search. Each night, there are only 2 10-minute windows when astronomers can observe the region, all because the sun's glare creates a very bright background glow. Plus, the atmosphere of our planet also distorts and blurs observations. Spotting asteroids in such conditions is beyond the capabilities of most telescopes. A really unique instrument is needed to fulfill this task, and the tool of choice is the Dark Energy Camera, DEC, at Cerro Tololo Inter-American Observatory in Chile. This device wasn't designed to hunt asteroids. Researchers built it to search for another elusive target, dark energy, the mysterious force driving the expansion of the universe. The DEC is supposed to observe hundreds of millions of galaxies. That's why it's both wide and deep. This way, it can both peer deep into the universe and capture a wide field of view, which helps it record the motions of galaxies and the conditions in the early age of the universe. But it also means that the DEC is perfectly suited to spotting asteroids near the Sun. Inner asteroids are rare, and deep images are necessary because such asteroids are faint. Scientists need to be able to fight both the bright twilight sky near our star and the distorting effect of Earth's atmosphere. And the DEC can help them achieve their goal. The Dark Energy Camera was built to carry out the Dark Energy Survey, which finished in 2019. Now, astronomers can direct the power of the camera toward other tasks. They claim that the DEC survey is one of the most sensitive searches ever performed for objects near Venus's orbit and within the orbit of our planet. It provides us a great chance to find out what kinds of objects are lurking in the inner solar system. Back in the day, from 774 to 775, Earth got hit with a megablast of radiation. This crazy burst of energy left its mark. Tree rings from that year show way too high levels of radioactive stuff. But what exactly caused it? Scientists are inclined to think that the reason was a solar flare. Some folks think maybe a massive supernova caused the radiation blast. But astronomer Phil Plait says that if that had been the case, it would have had to be less than 1,000 light years away and would have been crazy bright. But there's no record of that happening. No bright, shiny Death Star in sight. Some folks think maybe a massive supernova caused the radiation blast. Scientists ruled out a bunch of other possibilities. At first, they considered that it was a smash-up between neutron stars, or a neutron star and a black hole. These types of crashes produce a super quick blast of gamma rays without any light show, which lines up best with the evidence. But these kinds of collisions are super rare. Plait thinks it's kinda unlikely that this is the answer. He figures we should only see one of these events in our galaxy about once every million years. So having one just 1,200 years ago seems pretty wild. Scientists are seriously worried about these rare events. If one happened closer to Earth, it could seriously mess up life on our planet. Even if it was thousands of light years away, a similar event today could cause chaos with all the fancy electronic systems we've come to rely on. So, it's a good thing those gamma ray bursts are so rare, because if they were more common, Earth might be in for a rough ride. You may think that if our planet could withstand mega radiation blasts, it can easily withstand something less frightening. Let's say grasshoppers. Sorry to say that, but it's not exactly true. Back in 1874, during a hot summer in Kansas, things took a strange turn. Grasshoppers, or should I say locusts, invaded the Great Plains like nobody's business. They came down like a storm, blanketing houses, trees, and even poor trains passing by. These bugs were on a mission to cause chaos. Farmers had to scramble to protect their wells and just about anything else worth saving. Locusts landed everywhere, wreaking havoc on everything in sight. Even poor sheep lost their wool. Locusts even stripped paint off wagons and handles off pitchforks. This is how destructive they were. Livestock tried to fight back by eating them, but there were just too many of these insects. That year, those critters caused about $200 million in crop damage. The locust invasion was so tough, even the US Army stepped in to help. In the end, locusts began to disappear, sparing the plains from further devastation. Natural disasters can be even more unexpected than radiation blasts from space and locust invasions. Check this out. Back in June 2017, a reindeer herder up in northwest Siberia was minding their own business when they suddenly heard a crazy loud blast and saw smoke shooting up from the ground. If that happened to me, I'd need to change my pants, sorry. Later on, they found this huge hole that was like 7 meters wide and nearly 20 meters deep and was surrounded by chunks of ice and dirt. It turned out that there were over 17 such black holes in the area. They were filled with peaty water and shrouded in mystery. Some folks thought those were sinkholes. Others were sure they were left by top-secret device tests or even a bunch of meteorites.
Now, the latest idea is that these holes are actually craters caused by the Arctic warming up and melting the frozen ground. The theory states that as the ground thaws, gas pockets trapped beneath the surface burst through, creating such dramatic holes.
Apparently, these eerie craters have been showing up in specific spots in Siberia, where ancient geological faults have been leaking out hot natural gas for ages. Combine that with some leftover methane from old lake sediments, and you've got a recipe for some explosive surprises as the planet heats up. Not scared yet? Alright, maybe you're afraid of darkness, huh? If so, you wouldn't like it back in 536. It's the year when the world went through a crazy 18-month period of darkness. A mysterious fog covered Europe, the Middle East, and parts of Asia, blocking out the sun and causing chaos. It was like the Dark Ages, but for real. It turns out that the main culprit behind this fog was a volcanic eruption in Iceland. This eruption spread ash across the northern hemisphere, causing temperatures to drop and crops to fail. People were freezing and starving. It was a mess. Historians from back in the day even talked about how weird it was. The sun looked like the moon, summers were freezing cold, and even China had summer snow. It was all because of the volcanic ash blocking out the sun. And to make things even worse, this period of darkness sparked the beginning of the bubonic plague in 541. Talk about a rough time to be alive. Let's go back to Siberia real quick. Back in 1908, way out in the wilds of Siberia, an asteroid dropped in for an unexpected visit. Today, we know it as the Tunguska asteroid, but it didn't get its name instantly. Local folks only caught a glimpse of the show, a bright fireball streaking across the sky, followed by a massive boom. Trees went flying, fires blazed, and animals weren't too happy about it either. But since the area was so remote, not many folks took notice. For almost 2 decades, nobody bothered to check out the Tunguska site. People had too much on their plates back then. But then, scientists finally made it out there and found evidence of the asteroid's shenanigans. Later in expeditions, they found some spacey microparticles. Fast forward to now, and NASA has a whole planetary defense thing going on. They even sent a mission to test out asteroid deflecting tech, because who knows when the next cosmic rock will come knocking on our door, right? In the middle of the 19th century, there was one more epic solar storm called the Carrington event. It may not sound like a big deal to you, but it had pretty tough consequences. The next day after the storm, Earth was hit with this insane geomagnetic storm that threw telegraphs off the rails and brought auroras to the tropics. And it's the place where they normally never show up. Turns out, all this space weather madness started with weird stuff happening on the sun's surface, like sunspots. From these spots, solar flares and other crazy electromagnetic stuff can pop out and mess with our technology. Massive solar storms like this one can shoot out from the sun at speeds of up to 2,196 kilometers per second. They can contain billions of tons of solar material, complete with a sassy little magnetic field that loves to mess with Earth's magnetic field when they meet. Now listen closely. We're getting close to the next solar maximum in 2025, so it's a good time to check out the history of the worst solar storms like the Carrington event. And take notice. Imagine if a similar storm hit today, an internet apocalypse, anyone? Businesses would be sent offline, and we'd be facing some serious damages. Luckily, these mega solar storms don't happen very often. But hey, space weather is tricky to predict, so who knows when the next one will hit?